apologize in advance for your exam score. um, I'm sure it'll be fine. Don't freak out. Sorry. Let's see. Final homework. Open that. Well, that's not what I meant to do. I meant to open it as a PDF, but that's okay. And then open OneNote. Okay. Oof. Do you need a C- or better for it to count for circuits, or is it a C or better? I have no idea. Sorry. It doesn't say in the catalog. Oh, it's physics 1. Wrong thing. No, Gordon rule has to do with the writing requirements. Yeah, I don't know in that case. I feel like it should say in the catalog, and if it doesn't say in the catalog, I don't know if they can enforce it. Did it say above a C-? I don't know. Yeah. Yeah, that's true. I feel like it must be a C or better in order for the SU grading stuff to work. Because S is a C or better, not a C- or better. Yeah. All right. 17. Okie dokie. All right. So 17, the key here is that it's a one-dimensional situation. So you have, let me pull up a new session. Okay. I don't like this screen. This is too bright. You have like a child screaming, making a wave, and then you have another child screaming, making a wave, and then they're going to interfere the same way all the way along, right? Because at some given point, right, you have its distance from this person is x1, and the distance from this person is x2. So our phase difference is just the separation between them. Is our path length difference. So if the children are screaming in phase, that means in phase means that this is 0. So they are screaming in sync with each other. So delta phi naught equals 0. All right. And then essentially what the question's asking is, you're going kind of backwards for this problem, is you're trying to find delta x based on what delta phi is. And your other equation is a equals to a cosine delta phi over 2. Right? So if you know a, which for example for part B, it would be an amplitude 1.5 times greater than one child alone. So you would have A is 1.5 times greater. Right? You can solve for delta phi, and then you can solve for x. Hopefully that makes sense. Now the tricky part also is the one that's a sound that's half as loud. We talked about yesterday a little bit. Loud means intensity. So it has to do with the square of the amplitude. So there's a proportion. I just used a little pirate smiley face as whatever the constant of proportionality is. It's like in both cases, it's some number times a squared. And so what you end up with is something with the square root of 2 in it. So that one is a little more complicated. So Noah, let me know if that helped. Skylar asked, are there any formulas that are not on the formula sheet? Do you have an example in mind? I feel like most of them are on the formula sheet. Somewhere. Okay, let me talk about that one. So the part C is, we're lagging really hard. A sound that is half as loud as one child screaming. So half as loud is not about amplitude, it's about intensity. Loud equals intensity. So you know that one child screaming is going to be some value, and that you know the intensity of both. What you want is for this to be 1/2 the intensity of one child screaming alone. Okay. So how do we deal with intensity? Intensity is proportional to the square of the amplitude this, I think, was in the power and intensity videos that were on Canvas. So you can think of this as being, it's some constant times a squared. I don't like to use c because I think people get tempted to put the speed of light in there. So I tend to do some random other symbol. Ooh, like a heart. Where the heart stands in for just some constant. We don't know what. So I know that for one child, it's going to be that constant times the amplitude of one child squared. For both, it's going to be that times the new combined amplitude, where A is 2A cosine delta phi over 2. And you know that both is half of 1. So both is equal to half of 1. These constants cancel out. You end up with a squared is 1/2 a squared. A is 1 over the square root of 2a. And then this is what you plug in here. So you end up with 1 over the square root of 2a equals 2a cosine delta phi over 2. Does that help? No, it's the trick of half as loud means 1 over square root of 2 times the amplitude. Okay, so Ian asked about that one. Okay, so that one, you do have that formula, it's just not in that form. So I can see why that's a little confusing. Let me pull it up real quick. Noel, tell me if that seemed like it helped. Yeah, it did good. Yay. This one Ian was looking at. Okay. So this is an equation that you've seen before. Well, so this is an equation that combines two equations that you've seen before. So they're just kind of skipping a step. So what this is you have the force between, oh great. Let me make this bigger. There we go. Force between current carrying wires. The force on a current carrying wire is ILB sine theta. In this case, that's nothing. So this is the current in the wire. This is the length of the wire. This is the external field. So this is a wire in an external magnetic field. What is that field from? It's the field from the second wire, which is mu naught I, I'm going to call this I2 over 2 pi r. So if you plug this in here, you get I L u naught I2 over 2 pi r, which rearranges into the equation that they give. R and D, it's just sort of, it's interchangeable. L is the same as lowercase l, I1, I2. That's all it is. Okay, how do you tell whether do you add or subtract the force? It's a right-hand rule. Yes, so what you have to do is, so for example, you look at wire number 1. Okay, so wire number 1 is going to have a force from wire number 2 and a force from wire number 3. You think about each one by itself. So from wire number 2, that has a current going to the left. Hand wraps around, so it has a magnetic field going into the page at the location of wire 1, right? So wire 2 and is below wire 1, so wire 1 is up here, right? So wire 2 is going this way. At this location of wire 1, it's into the page. So you have a wire that is in an external field that is going into the page, and that has a current going this way. So then you do right-hand rule, F is I, L cross B. So I is your thumb, or L is your thumb, B is into the page, F is up. So the force of 2 on 1 is up, and then you do the same thing for the third one, right? So the third wire, okay, has the current going to the right. So above it, where you have wire 1, it would be coming out of the page, right? So we have wire 1 still has our current going this way, but now our external field is coming out. So we do I cross B is F. So F of 3 on 1 is down. So in this case, you would subtract. One of them would be positive, one of them would be negative. Okay. Hopefully that helps. This is a complicated problem. It's multiple equations that are combined, and it's multiple right-hand rules. Yeah. So Skylar asked about final exam problem sets. Was that in the recitation section? It looks like it was in the recitation section. Okay, let me pull that up. Oh no, I can look in here. Was it one of these? Top. Is it this one? All right, I'll stop moving it. Is it this one that I'm hovering over? Is it this one? Okay. Nine pages, good Lord. Oh, I see. This is why you were asking about drawing snapshot graphs. I didn't look at this. Good God. 2 out-of-phase radio antennas. Those locations. Oh, this is an equation you already know. This is just like the 2 speakers. So you have 2 sources. 2 sources. One's right here, one's right here. You have a location of interest. So where you want to know, and so for this case, it's directly in front of one of them, and you want to know. No, there's several of these on the final homework, right? It wants to know, is that point what kind of interference? So you're like, okay, I need to know what kind of interference it is. Any question that asks about what kind of interference means I want to think about delta phi. How do I get delta phi? Delta phi is 2 pi over lambda delta r plus delta phi naught. So we know that they are out of phase. So out of phase means delta phi naught is pi. And then lambda we can get because we know it's the speed of light. This trips up students a lot. They think radio must be sound because they're like, well, I listen to the radio and it's sound, right? But radio is a kind of light wave. It's weird. So you find lambda using C and the frequency. And then delta R is you do, this is R1, this is R2, and you do delta R is R2 minus R1. Yeah. This is the same as in the final homework. There's the 2 loudspeakers, the 2 losing League of Legends players. So you know how to do it. You're just freaking out because it's like antennas and it's a crazy drawing. So let me have a look, I'll tell you. You don't need to know how to draw a snapshot graph because we don't know how to grade that. That's good practice. Yeah, good practice. Ooh, that's good. I mean, these are good practice problems. If you have run out of, if you've done the final homework, this is a good way to get some more practice. None of these should be that unfamiliar. So even I would recommend using these as almost like a practice test. Like, can I do these without looking at my homework? So Skylar, I think you might just be like psyching yourself out, because this is just like the two League of Legends players. This is yeah, you've seen before. It's this, the EMF equals VLB. Right? That you've seen before. This one's a little bit weird. This one is like you have to do some calculus. So I will tell you that you don't need to do this level of you have to do calculus for this. But this E dot A, right? You know that? That's a totally logical. Hang on, OBS is trying to record and I don't have any space on my hard drive. I don't know what it's doing. No, I think that you're psyching yourself out. That you have seen these, you know these. So what I might recommend is, well, I would say to look back at your homework, but I still have homework too, and I can't give it back to you. But if you look at previous homework problems, you should be able to be like, oh yeah, we did this, right? We've done electric flux through a rectangle. These are all KQ over R. We've seen KQ over R. I think the fact that there's like slight differences, like they use 1 over 4 pi epsilon naught instead of using K. So, Logan, you want to do number 22? Sorry, I don't know why Twitch is not showing me the chat in OBS. That's really annoying. So, all right, we'll do, and Noelle asked about 26 as well. So we'll look at 22 and 26. Skylar, I think I would recommend you look at the formula sheet and go through it, like, just like really, like obnoxiously slowly. Is the formula sheet in here? It should be. Wow. It's too much stuff. No. But look at the formula sheet and be like, okay, remind yourself, like, you know all of these formulas. Like, start with that as your, start with that as your, like, is this the right one? No, I think this one is. No, this one is. No, this one is. Very, very organized. So I think your thing is like, oh my God, I've never seen this formula before. I don't know what I'm doing. If you start with, okay, I have seen this before. There's nothing on the exam that should be like, I'm seeing this for the first time, right? So if you start with this idea, okay, I have seen this before. I just have to figure out, and I know it's on the formula sheet, I just have to figure out which one it is. And then, like, go through, like, one at a time. And they're in categories, which helps, right? Am I talking about RC circuits? Am I talking about electric fields? Am I talking about inductance? Right? Am I doing waves? And it helps to start writing down all the knowns. Gabrielle is a really good idea. Because then you know what variables you're looking for. You're like, oh, do I have an equation that has a Q and an R in it? It's really helpful. Oh no, that never helped. End up misinterpreting. Oh no. Misinterpreting like you picked the wrong equation. Oops. Sorry. Oh no. I mean, some of it is just my voice being very crackly because I just woke up. Also, my internet, I think, was having trouble. Is the mic any better, or is it still bad? Okay. I gotta auto-tune my lectures. So that might be, if you end up picking the wrong equation, that is actually like the risk you take when you're just kind of like, which equations have these letters in them. You can end up picking the wrong equation, that's very true. So if you kind of try to go by category first, if you can, you're like, I know it's in this box, and then see if you can put into words what each equation is for. You're like, okay, Ohm's law is how I would find the potential drop across a resistor, or how I would find the current through a resistor if I know the voltage. So I would use this if I'm analyzing a circuit, right? Or like Joe, our friend Joe. So it's lagging really hard. J is the current density, right? So current divided by area, so sort of thinking about like flow through a pipe almost. Sigma is the conductivity, E is the electric field. So I would use this in a case where it's asking me about the electric field inside a wire that's carrying current. That's not something we get asked about a lot. So if you're asked the electric field to do with current, you might want to look at this equation, right? So Logan asked about T and lambda. So T is period. So T is the time it takes, like if you have like a string, right? It's the time it takes a point on that string to make one complete cycle and get back to where it started. So T is always measured in like seconds or minutes or hours or something like that. Lambda is the physical distance between, like, so like my wave goes up and then down and then up again, right? And as that is happening, the crest is like moving along. Wow, this is lagging so hard. Oof. Okay. Yeah, C is on the sheet. Yeah, and speed of sound, I think, might be on the sheet. I don't remember. Yeah, speed of sound is 343. C is the speed of light in vacuum, right there. Surface area of a sphere is not. That's true. You gotta remember it's 4 pi r squared. That might be worth considering putting on here, actually. Okay. So this is interference, which is sort of just, it's a lot of stuff. Can I take those out? Right. So if you think about an individual point, it's going to be the time between one crest and the next crest, right? By the time it reaches that next crest, right? So right now at this point, there's a crest. So then I move it on for a bit. And now at that same point, there's a crest. How far has the previous crest moved during that time? Will it move this distance, which is lambda? So you should not. I think we would consider that cheating, which I think it sucks, but sorry. So one question is like, when you're looking at a graph, which is it? So the key for that is you have to know whether this axis is time or distance. Because if you have a graph that looks like this, and it's like, okay, what is this? Is this wavelength or is this period? It depends on whether this is x or t, right? If it's time, then this would be period. If it's distance, then this would be wavelength. Does that make sense? So you're either recording what one did over time, and it's like, okay, this is 2 seconds and this is 6 seconds. So my period is 4 seconds between these two crests, right? Or if you have x, this is 1 meter and this is 2 meters, you would say, okay, my lambda is 1 meter because that's the physical distance between these two. Does that make sense? All right, somebody wanted to look at 22. 22. Okay. So 22 is about pattern recognition. So that is, I talked about this yesterday. But I feel like this is not useful to look at. There's too much stuff there. So basically, there's different patterns for open, open. There's open, 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 close. Oh, why does it do that? You have open, open, closed, closed, and strings all have the same pattern. The lambda is 2L over M. And they all either kind of look like this, right? Or for open, open, it's the other way, right? But in both cases, there's like 2 nodes and 1 antinode, or there's 2 antinodes and 1 node. And they all follow this pattern. For an open-closed tube, you have a node at one end and an antinode at the other. So instead of being 2L over M, it's 4L over M. Tears land on the page. If your tears happen to form the shape of a formula, then no. I mean, if you could get accommodations, it's worth pursuing them. But The end of the SpongeBob movie. I have not seen the SpongeBob movie. So the next one you would think would be like this, but it can't be a node at this end. So this is m equals 1, m equals 2. M equals 2 is not a standing wave. So you have m equals 3 is like that, where you have an antinode at that end. M equals 4 doesn't work. All right, while y'all are taking the test, I'll watch the SpongeBob movie. All right. So basically, you have two options. You have 2L over M. You have 4L over M. This is M equals 1, 2, 3, 4, etc. This one is 1, 3, 5, 7, etc. And then for 22, your job is to figure out which pattern it fits. Yeah, back-to-back sucks. Sorry. Boo. Oof. I posted solutions for test 3. Oh, I see. That's what I was confused about. Test 1, you corrected it yourselves. And I think I gave those back, but it might be in the possession of one of your other team members. I don't remember for test 2. There was, and I don't think I've put it in yet. I have to go and look. My grading is miles behind. When would you say final grades will be in? Well, we have a deadline. Final grades are due. Let's see. I'm going to turn off my screen share while I look at my email. Nice. Yeah, there was extra credit for that way back in the day. Let me see if I can find final grades due. Well, final grades are due for submission Monday, May 4th at 4 p.m. Yeah. So that's the latest they're going to be done. That's true as educational use. Wow. Is this just like the MP4 file? How big is this file? Oh, I see. Wow. There's almost like 10 whole pixels in this image. 44 megabytes. That's why it's only 44 megabytes. Wow. Right, maybe it's on like an actual streaming service. Let's see. I feel like we've reached the like punch drunk stage where it's like you've studied really hard and now it's just kind of like the goofiness is taking over. Oh yes, can we discuss 26? Noelle Goes Away comes back to the SpongeBob movie. 26. Aha. No. No panic. Deep breaths. Like you can do this. Like, I am 100% sure. You just have to remember that you can do it and not freak out and be like, oh my god, I have no idea how to do this. I've never seen this before. You can do it. Start from that assumption. Yeah, basically. Yeah, stay calm. I know it's easy to say and harder to do, but stay calm. You'll be fine. Come back to problems to look hard, yeah. Gabrielle's got the tricks here. Paul Rudd is a very uplifting experience. All right. You're standing directly in front of the two loudspeakers. They're both playing this tone. As you begin to walk directly away, at what distances do you hear a minimum sound intensity? Okay, so the first question is, what do you hear at that specific location? So that is, you have, what is it? Two speakers that are 3 meters apart. And you are 2.5 meters in front of one of them, is that right? Yep. They're playing a 686 hertz tone in phase. Okay, and then you walk directly away. At what distances do you hear a minimum sound intensity? Oh. Don't think too hard. Yeah. You can do this. So write like a little mantra at the top of your test. It's like, I know how to do all of these problems. And you're like, oh my god, I'm freaking out. And then look at it and read it and say it out loud. I know how to do all of these problems. You just have to like dig it out of your brain. Yeah. I know it's easier said than done. I feel like the luckiest thing for me is that I don't get test anxiety. Like, if I had test anxiety, I think I would have had a much harder time in school, for sure. It is a bit of a group therapy session. So, you can do this. I believe in you. Definitely can do this. Okay. So, this problem. Yeah, that's true. Think of it like a practice test. You can always get an S if you need to. Ooh. All right, Noel. I think that while the therapy session is going on in the chat, what does it mean that they're in phase? Can somebody tell me what that means? Phi naught equals 0. Yes. So they are making a crest at the same time and a trough at the same time. Right? They're not out of sync with each other. Not necessarily constructive. If it was, if you were at a point halfway between, it would be constructive. If you're at any point where delta R equals 0, it would be constructive. But because the wave takes longer to get there from one of them versus the other, they both make a crest at the same time, but when the crest from this one gets to this dot, the crest from here hasn't reached there yet. So by the time the crest from this one, the further one reaches it, the crest from the closer one is already passed, and maybe it's a trough. Maybe it's the next crest. That's where we have to kind of figure it out. Okay, so 686 hertz. Why did they give us this information? What good does this do us? We need to find a lambda. Yeah. So V equals F lambda. V, is this sound or light? It is sound. So 343, and I made life really easy for you. So lambda is 1/2 meter. Okay. So whenever we're doing interference, which we're doing interference in this case, right? We're looking for minimum sound intensity. That happens when there's destructive interference. We always want to do delta phi. And we know the equation for delta phi. Okay, we know this is 0. We know this is 1/2. So we end up times delta 0.5 delta R. So I can actually rewrite this as 4 pi delta R. Does this make sense? Okay. So at this specific location, what's going on? Well, we have R1 is 2.5. R2, that does not look like an R. It still doesn't look like an R. Close enough. Square root of 3 squared plus 2.5 squared is square root 3.9 meters. Okay, so our delta R is 3.9 minus 2.5. Remember to subtract. That's what trips up everybody. They forget to subtract. So I get 1.405. Okay. So we plug that in. Our delta phi is 4 pi times that. So it's 5.6 pi. What type of interference is that? Destructive? Is it constructive, destructive, or something in between? So a way to check, you can't remember, times pi divided by 2, radians, cosine, times 2. So I get my combined amplitude is 1.65 times A. So it is constructive because it is bigger than 1, but it's not maximum constructive. Right? Max constructive happens when A equals 2A. Okay. Is this making sense? Hopefully. Right. As you walk away, your R1 gets bigger and your R2 gets bigger. So we have delta R is R1 minus, well, R2 minus R1. R2 is the square root of the distance between them plus that R1. Is this getting bigger or smaller as you walk away? It's really weird. I might graph that. Oh, puppy. See my random stuff that I'm looking at. Trying to get my able seaman license. What are we doing? Sorry, there was a dog. It was very distracting. Okay, so square root of 9 minus x squared. 9 minus, it should be plus. Minus x. Okay, so this is what delta R looks like. When delta R, when R is 0, so when you are standing right here, this R is 0, this one is 3 meters, but then as you walk further away, right, the difference between them starts to matter less and less, right? By the time you're standing 6 meters away, there's only a 0.7 meter difference between those two distances. Does that make sense? The further away you are, the smaller the difference in how far each wave has to travel. So we know that as you walk further away, delta R gets smaller. So that means what about delta phi? Delta phi has to also get smaller. So it is going to decrease from 5.6 pi down to 0. You'll never actually reach 0, but it's asymptotic. It's going to get close. Okay. Decrease from 5.6 down to 0. Okay. So, at what values of delta phi between those points will you get destructive, perfect destructive interference. So this is where we think back. There are certain values of delta phi that will give you perfect destructive interference. What are those values? This I need y'all to tell me. Well, I mean, I don't need you to tell me. I do actually know the answer, but I want you to tell me. This is an important thing. Aha, Annie suggests pi, 2 pi, 3 pi. Think about what happens when you plug those into this equation. You're partially right. So remember, it's about whether they're lined up or not. So whether they're off by a half cycle or a whole cycle. So if it's off by pi, that's off by a half cycle. Crest will line up with trough, destructive interference. If it's off by 2 pi, that's a whole cycle. Crest lines up with crest. You get constructive. 3 pi, yes, odd pies. Etc. Okay. So, can you tell me the ones that are in this range? So, just these three. So, now we need to know what value of delta R will give us these values of delta phi. And then we can solve for what values of R1 and we'll have 3 answers. Does that make sense? Noel, did this help? You were the one who asked about this one, I think. This is tricky. The main idea is this, and then sort of applying it to figure out where along that line it's true. So I'm going to be super lazy and I'm going to graph this. So we know that this is 2 pi over lambda, which was 0.5, times that. So now I'm graphing delta phi as a whole. So, okay. Note that it goes up. Zoom. Okay. All right. So we want every value where delta phi is, oops. So I want to know when it's equal to pi, when it's equal to 3 pi, and when it's equal to 5 pi. Can I just do y equals, y equals, y equals. Okay. So I know one of them happens at when x, our distance, our horizontal distance is 2.95, which is further than 2.5, so that's good. Then at 5.625, and then at 17.875. They're not just multiples, because it's a weird square root relationship. But those are your answers. Should be right. Will the exam be available a little before 1 p.m. so you can print it? That's no, not the plan, sorry. Hmm. I'm trying to think if there's anything we can do about it. I think we talked about this. So what I would do is send it to print and like look at maybe the multiple choice or like one question while it's printing. Sorry. Yeah. Yeah. How long does your printer take? Hopefully not that long. That's okay. Yeah. So I know it's not ideal, but so it took me, I want to say like 15 or 20 minutes to do it. You do not have to print it. You can print it if you want. It is an option. It is just a PDF like it was for exam 3. Yeah. So now that's not as reassuring as it might sound, because sometimes the general rule of thumb is that it takes students somewhere between 3 and 5 times as long as it takes a professor. And I had seen a previous draft, so it's probably closer to 5 or 6 times, but that's still like only an hour and a half. So I think that hopefully you will not run into time difficulty. I mean, I am, like, literally. like this is my job. And it's like, I've given a lot of these tests, so, I know how they work. But that's why it's like it's supposed to be like, generally rule of thumb is 3 to 5 times. And so 3 to 5 times, it's still less than 2 hours. So I don't think time will be an issue as long as you don't freak out, Skylar. Annie asks, can you just write work and numbers on printer paper? Yes. Totally fine. You do not have to print it. Do try to make it organized so that I can see it. Like, I can tell where your work is. Sometimes students treat it like scratch paper, where they're just writing it all over the place. I'm like, that's not gonna help. Like, try to at least like make a box and put your stuff in that, area. Yeah, don't do it like I do. My stuff is all over the place. So. It's okay. You will be fine. I am confident that you will all do fine. That there are no questions on it that I thought are, like, a lot of times I'm like, I think this question's really hard. Some of the long answers I think are easy enough to be short answers. So my big note for you is do not overthink it. If you're like, this seems really easy to be a 10-point problem, some of the 10-point problems are really easy. Like, don't forget. Don't forget. So, like, we understand that y'all are under a lot of pressure right now, and that this is an unprecedented situation. So, I'm just thinking, I was a freshman in college for 9/11, so you can work out how old I am if you're interested. And I'm just thinking, like, it's weirdly grateful that it was September, so we didn't have to take finals, like, right afterward. So, y'all are in a worse situation. The online stuff has been pretty, like, crazy, and I know for a lot of professors it's been, like, more work, and I know I've given you the little Canvas quizzes that are, like, extra work, but I think you should be proud that you're, you know, oof, that's rough. But yeah, you should be proud that you're dealing with an incredibly difficult situation, and you don't really have the luxury of just sort of like taking a break, you know. I had a homework last night. I don't know. I make stuff do, but I usually say, like, if you do it later, like the post test, I will make y'all a participation medal. Passed physics 2 in a pandemic. So there's the post test for me that says it's due, but if you do it after the test, it's fine. I just put that it was due before the test to encourage you to do it for practice. I mean, Team Low Expectations generally, I think, would have come out the winner. No offense intended to teams Pink Floyd and Supercalifragilisticexpialidocious. Yeah. Room scans, that's freaky. Yeah, I'm not in the school place. I'm having a really hard time with it too. Like, I don't even know how y'all handled it. Who had the most points? I think Team Low Expectations did, but I essentially stopped thinking about it like a month ago, so I think due to the fact that we all separated, I think the teams were disbanded essentially. Oh no! That's weird. That's like, so for me, you know, like those scanners at the airport? The scanners always think that my left ankle is suspicious, and now I've gotten like self-conscious about whether there's something weird about like the shape of my left ankle. Like, it looks normal to me. But yeah, so Proctorio, you're like, is my face weird? Like, what is wrong with my face? Yeah. Maybe I do. That's true. So I would be happy to bring you all cookies whenever we get back to campus. Whenever that is. Sometime in the distant future. So last year I made physics formula cookies, and I wrote formulas on them, and if you could tell me what the formula was for, you got to eat the cookie. But it turns out it's really hard to write formulas on cookies, so some of them weren't that legible. I'm sure I have a picture somewhere. If I find a picture, I'll post it for you. Oh. Well, hopefully I'm going to teach modern physics. But we have not actually scheduled that again. Oh. That's so sweet. I would love to have all of you as students again. But I hope I don't, because that would mean that you have to retake physics too. So, it's been fun. And if anybody has any like physics related questions, you know, let me know. I'm probably gonna stick around until about noon. So I'll try to find my cookie pictures. But then I opened my phone and I forget what I was doing. Months. In December. Oh, they're there. That was just
Bye bye, gamers.
All right, Ian says bye. Bye, Ian. Bye, Gabrielle. We gotta study for programming. Anything that would help for the test. All right, bye. You're very welcome. I hope it was helpful. I really want you to do well, especially because then I can lord it over the other physics professors. Bye. So, Skylar, if you want to stick around, you're welcome to. We can talk about more of the PowerPoint questions or anything like that if you want. Anything really. Just don't freak out. Don't freak out. That's I think your biggest thing. You're your own worst enemy. Like, did you do all the final homework? Yeah? Does it make sense? Meh. Okay. Can't retain anything. Okay, that sounds like you're an emotional state issue more than here, let me turn off the Twitch stream.